Hello, my name's Andrew Williams and I'm an area manager here at Scalar Analytical in the Netherlands. Today sees part 3 of an ongoing series of videos in which I answer the 5 most frequently asked questions that we receive via our website. And today we will be focusing on our PRIMACS series of carbon and nitrogen analyzers. So in order for me to best answer the questions we've gathered up, I've moved to the production and testing facility here at Scalar for the PRIMACS units, and I'm now standing with our PRIMACS SNC 100 unit. So question number 1, what is the real amount of sample I can analyze? So yeah, we do specify that a sample weight of up to 3 grams can be analyzed. That doesn't mean we actually have to analyze 3 grams of every sample, but what it does allow customers to do is use higher nominal weights. Because we are talking about a macro analysis, not a micro analysis. And what this means is that your results will actually be much more representative of the sample itself. It also reduces the pressure on the quality of the sample homogeneity, so there's no need for really advanced sample prep techniques. Just the usual drying and milling is absolutely sufficient. Moving to question 2, what is the sample preparation for our direct IC measurement? So that's inorganic carbon. Do I still need to do any offline acidification? Well, actually what we offer is a fully automated analysis of IC by acidification. So what would normally be an offline step where you acidify the sample offline and then run the sample as TC on the assumption you have removed all of the inorganics, what we've actually done is automate that whole step. So the samples are introduced into our IC reactor, they are acidified and sparged, and the carbonates and bicarbonates are immediately liberated from the sample and moved directly to the detector, and then the software will simply calculate TOC as TC minus IC. So you have a huge time gain by not having that additional offline drying and acidification step. Instead, you have an IC measurement in 5 minutes. Moving to question number 3. So with carbon speciation in mind, so that's the measurement of organic carbon, elemental carbon, and inorganic carbon. How exactly does the temperature ramping methodology work, and where are these parameters typically analyzed? So in waste management, it is necessary to differentiate between the types of carbon within a sample, whether that's a soil sample or a soil type sample, a sediment or a sludge. In soil management, high TOC levels can actually prevent anaerobic digestion processes and actually limit nitrogen enrichment in the subsoil. Typically in the past, when you had a simple TC minus IC methodology, the elemental carbon portion of that sample would have been included in your TOC value. So now with this exclusive technology, we are able to differentiate and break down the carbon profile of the sample as a whole. So now that we've established why we need to analyze these parameters, let's take a look at how we analyze these parameters by taking a look inside. So as the samples are transferred from the auto sampler on the right, they are injected vertically into our combustion oven. This oven is temperature profiled, which means that at a certain height, there will be a certain temperature. So by positioning the samples at those certain heights, we are able to temperature differentiate the carbon species. So moving from low to high, you will have your organic peak, your elemental peak, and then your inorganic peak at the higher, hotter part of the oven. Also, it is worth adding that thanks to that exclusive and patented technology, no heating or cooling of the oven is required, which means that we can achieve a full carbon profile analysis in around 20 minutes. So that brings us nicely to question 4, which was, what are the cleaning steps to remove ash and residue from previous samples from the combustion oven? Well, as you saw in question 3, we are using a vertical injection method, and what that actually means is that the crucibles containing the sample actually become actually becomes its own waste receptacle. All the ash, all of the residue, the combustion residues stay in the crucible and are removed from the analyzer and taken back to the autosampler. So this, you actually totally avoid the buildup of ash and residue in the oven. So no need to open up, clean, leading to downtime and so on. So that brings us nicely to question 5, which was, without using tin foils or flash combustion or any other post-combustion steps, how do we ensure a complete combustion of the sample? Well, basically, the gases produced during combustion, so we've injected vertically our sample, the sample is now combusting in the oven, and those gases generated are actually recirculated multiple times through the combustion oven. So we know that the sample gases have a maximum contact time with the oxygen to really achieve that complete combustion. Also, by not using tin foils and things like this in your sample prep, you actually save hours of tedious sample preparation time. You actually remove an additional ongoing cost of ownership. And by having these reusable crucibles and not requiring tin foils, what that does also allow is us to analyze more liquidy or pasty samples, which is absolutely a requirement, for example, in the food laboratories that we serve. So all that's left for me to do is to thank you for watching and for your attention. I hope you found that informative. If you require any more information about our PRIMACS series of carbon and nitrogen analyzers, please visit www.scalar.com. Thank you very much.